Welcome to a deep focus strategy session. Go ahead and take a slow, settling breath. Let your shoulders drop. Today we are calmly and methodically decoding Cambridge AS and A-level mathematics, specifically targeting the logic behind numerical solutions and iterative methods. We are focusing entirely on the formula xn+1 equals f of xn. Let's clear our digital workspace, shut out all the external noise, and scan the examiner's playbook. We are going to approach this complex mathematical architecture with total serenity. No rushing, no exam anxiety, just pure, calculated logic.
Okay, let's look at this jarring truth straight from the principal examiner reports. It is a striking reality that most students lose easy marks on iterative methods. They literally leave points on the table. But after this session, you absolutely won't be one of them. We need to shift our perspective right now to see exactly what the examiner sees when they look at your examination paper. To really understand this, consider two hypothetical scholars joining our conceptual study space today. Let's call them Alex and Sam. Now, Alex is analytical and highly precise, but Alex tends to crowd the page layout. They fill their paper with unstructured mathematical facts, jumping from equation to equation without any clear narrative flow. Then we have Sam. Sam is creative and dynamic, but Sam is incredibly prone to losing focus on specific command word parameters. Sam rushes to the final numerical answer without showing the journey, completely ignoring the structural boundaries of the question. The examiner doesn't just want the final destination, They want to see the calm, structured path that both Alex and Sam took to get there. They want to see the gears turning in your mind, laid out flawlessly in ink. The marks are absolutely there for the taking, provided you demonstrate structural discipline and total clarity.
Here is our minimalist study roadmap. It's designed to help you methodically deconstruct complex questions without a single drop of exam anxiety. First, we're cracking iterative methods. Second, we'll align with core principles and objectives. Third, we master the method mark strategy. Fourth, we'll flow through the standardized exam sequence. Fifth, we'll neutralize the top 3 examiner warnings. And finally, we'll secure that top-tier evaluative edge.
Section 1. Cracking Iterative Methods. Let's calmly decode the multi-stage analysis.
Now, what's really interesting here is that your ultimate safety net is the method mark. It's the exact structural process examiners are hunting for on your page. When decoding a multi-stage analysis, it is incredibly easy to let your visual layout become cluttered and your logic become tangled. But an iterative method, at its core, is simply a pristine feedback loop. It's a beautifully constructed mathematical machine. You take a starting value, your x0, and you calmly feed it into the engine. The engine hums, processes the data, and produces a brand new value, x1. You then take that new value, x1, and you calmly feed it right back into the exact same machine to get x2. It's rhythmic, it's predictable, it's soothing. But here is where our scholars slip up. Alex often writes down a brilliant final answer, maybe accurate to 4 decimal places, but skips the intermediate substitution steps, assuming the examiner just knows how they got there. That's a massive mistake. Sam, on the other hand, might write down a few messy, overlapping steps, lose track of the subscript notation, and arrive at the completely wrong answer, losing everything. The method mark bridges this gap. It explicitly rewards your logic, your calm structure, and your clear extraction of relevant data. Did you explicitly write down your initial value? Did you show the physical substitution of x0 into the function f? The examiner wants to see the architecture of your thought process. They want proof of your systematic execution.
Section 2. Core Principles and Objectives. Let's peel back the curtain and look at exactly what examiners want to see.
Cambridge explicitly targets these 3 distinct cognitive domains, keeping our focus incredibly sharp on how we apply and analyze the math. Let's break this down by looking at how Alex and Sam might tackle this in a shared digital workspace. Imagine them collaborating on a complex, high-tariff question. First up, knowledge and understanding. Alex meticulously maps out the textbook definitions line by line, setting up the framework flawlessly. Alex knows that an iterative sequence is designed to converge on a root. But then we hit the second and third domains, application of mathematical frameworks and critical analysis of data. Here, Sam jumps into the debate. Sam challenges Alex's rigid framework, pointing out that they can't just list numbers, they have to actively analyze the data stream. Sam says, wait, look at the values our calculator is spitting out. Are they converging in a steady direction, or are they oscillating back and forth across the root? They debate the structural framing of their argument blocks right there on the digital page. Alex writes the exact sequence values, and Sam explicitly writes down the logical conclusion of those values. Critical analysis means looking at that cascading sequence of numbers and proving to the examiner that you are actively engaging with the mathematical narrative. You aren't just a calculator, you are the analyst guiding the data.
Now this is absolutely crucial. Iterative methods do not exist in a vacuum. Proving your theoretical architecture integrates with other syllabus areas is the literal secret to unlocking top-tier scores. When you were using the formula xn+1 equals f of xn, you were essentially looking for the intersection of two graphs on a coordinate plane. Usually, that's the line y equals x and the curve y equals f of x. A top-scoring candidate doesn't just see a string of floating algebra, they see coordinate geometry. They see the entire board. In their mind's eye, they see the graphical staircase or the cobweb diagram slowly spiraling inward, step by step toward that perfect point of intersection. If a question allows for it, calmly and clearly referencing these cross-topic connections shows the examiner that you possess a comprehensive, elevated understanding of the entire A-level mathematics landscape. It demonstrates that you have taken a breath, zoomed out, and understood exactly how the geometry drives the algebra, and how the algebra proves the geometry.
Section 3. The Method Mark Strategy. This is where we build our theoretical architecture and secure every possible process mark. By structuring your page layout with these strict conventions, you protect your focus and prevent losing silly points on presentation and format. But actually, before we write out our final top-band paragraph structure, let's breathe and refocus. Let's pause our on-screen execution for just a second. Make sure your daily study dashboard is complete. Subscribe to Ace the Exams right now and enable all notification alerts. Whether your target is an IGCSE, an O-level, or an AS and A-level A-star, this channel is your weekly space for stress-free exam mastery. Okay, focus restored. Let's get back to the framework. Imagine our scholars hitting a structural roadblock mid-paragraph where their evidence just drops out of alignment. To fix this, we use a clear visual structural framework. You can think of it like building a logical scaffold. First, you must rely on precise definitions. Second, establish clear causal relationships. We will explore cause and effect deeply in just a moment. But look incredibly closely at the execution. Clear notation. Are you writing x subscript 1, x subscript 2, x subscript 3 with pristine, undeniable clarity? Or are your subscripts floating ambiguously somewhere in the middle of the line, looking like a multiplier instead of an index? That is a fatal error. Are you presenting with correct terminology? Don't just generically write "it stops." Write "the sequence converges to a root." Ensure proper headings and clear annotation. If the command word asks for a result to 4 decimal places, your clear annotation should explicitly demonstrate that exact rounding process. Calm, structured, visually logical.
Section 4. The Standardized Exam Sequence. This is your step-by-step methodology.
This precise 5-step sequence is your marks per minute flow formula. You need to memorize it so you can systematically process literally any iterative problem thrown your way. Let's walk through the interactive practice arena. Step 1. Deconstruct the question. Use your mindful scan. Display a highly complex question in your mind. Let the 60-second visual countdown timer start and cleanly highlight only the exact iterative formula and the required degree of accuracy. Strip away the filler. Step 2. Extract relevant data. What is your starting value, your x0? Pull it out of the text and write it at the very top of your pristine workspace. Step 3. Select the analytical framework. This is where you set up your calculator with absolute efficiency. Type in your initial value, hit equals. Now, carefully, methodically type the mathematical formula using the answer button. Step 4. Execute with clear notation. Press equals. Write down x1. Press equals again, write down x2 line by line. Do not skip a single iteration. Create a visually satisfying column of data. And finally, step 5. Present with correct terminology. State your final answer and confidently logically declare that it represents the root correct to the specified decimal places.
Section 5. Top 3 Examiner Warnings. Let's smoothly navigate the common pitfalls that destroy standard responses.
The principal examiner reports highlight 3 massive, glowing red flags that we must consciously and explicitly avoid. We are going to look at each of these 3 warnings, calmly break them apart, and neutralize them so they literally never impact your final grade.
So, the crucial point here is mistake number 1, confusing cause and effect. You must calmly and clearly separate your inputs from your derived outcomes. Think about the standard formula, x subscript n+1 equals f of x subscript n. The cause is the entire right side of the equation, f of xn. It is the mathematical trigger, it is the previous known value that you are plugging into the function. The effect is the left side, xn plus 1. It is the resulting outcome, the brand new evaluated value in your sequence. Examiners repeatedly report that students frequently confuse the index n. They plug the wrong sequence number back into the formula, or they mix up their current term with their next term in their written explanation. You have to treat this like a perfectly organized digital ledger. The input from iteration 1 becomes the cause for iteration 2. The effect of iteration 2 instantly becomes the cause for iteration 3. If you maintain serene, disciplined notation, keeping your causes perfectly aligned with your effects, this mistake will never happen to you.
The remaining examiner alerts remind us that dropping our precise formats or writing generic, unlinked answers will instantly hemorrhage your hard-earned marks. Let's enter Challenge 2 of our practice arena, the imperfect answer. Picture a flawed student paragraph on a screen. The math is technically correct, but the structure is entirely chaotic. Where does structural discipline break down? It breaks down when the student forgets to check format and presentation. Imagine their decimal places are wildly inconsistent, jumping from 3 decimal places on line 1 to 5 on line 2 and down to 2 on line 3. The examiner immediately docks marks for a lack of presentation conventions. Or worse, the student provides a generic answer. They write something like, "the sequence finishes," instead of actually linking to the specific scenario. If the problem is about modeling population decay, your final sentence must explicitly state, "the population of bacteria converges to 4.5 million as modeled by the iterative route." You must always link every single mathematical point back to the given contextual scenario. Use your clean, structural framework to restore balance to your text.
Section 6. Getting the evaluative edge. This is how we reach the absolute top-scoring bands and craft an examiner-compliant masterpiece.
This brilliantly illustrates what top candidates actually do. They evaluate evidence quality by questioning assumptions and proving their logic through strict, justified steps. Problem solving at the highest level uses a deconstruct, solve, and evaluate mindset. Look at these bullet points closely. Did you identify limitations and assumptions made? For example, an iterative method might completely fail to converge, it might spiral out of control if the starting value x0 is chosen poorly, or if the gradient of the function is simply too steep near the root. A top-tier student recognizes this limitation immediately. Consider alternative interpretations. Justify your decisions with hard evidence pulled directly from your sequence data. And finally, check for reasonableness in the final answer. Does your calculated root actually make sense in the real-world context of the original equation? If you are calculating a physical length or a volume and your iterative method converges on a negative number, your mindful evaluation should immediately catch that something is structurally wrong. Justify, check, and refine your logic until it is completely bulletproof.
So, how will you evaluate your answer? As our focus meter maxes out at 100%, let's distill this entire masterclass into 3 core focus pillars. Pillar 1, the 3-step question scan for pristine decoding. Pillar 2, the marks per minute flow formula for systematic, stress-free timing. And Pillar 3, the final polish review pass to guarantee your evaluative edge. You now possess the exact architectural blueprint required to calmly deconstruct complex questions and secure every single mark. Before you turn the page on your next exam, take a mindful breath and ask yourself, have I truly justified every step of my method to the examiner? To keep building your perfect study system, make sure you subscribe to Ace the Exams. Click the notification bell for our future focus deployments, and leave a comment below identifying the specific subject, tier, and target grade you are currently meditating on. Stay calm, stay structured, and I will see you in the next session.